Okay, welcome on board, guys. We'll start with the electric. So, there was last lecture. Sorry, oh, okay, it's my fault. Okay, so then maybe the bit of the thing. So, I have taken carefully, but today we start with the topics. So, okay, just give me a second. Okay, there is my pen. There is my pen. There is my tool. Okay. So how it's going, guys? If you are enjoying this, my job is done. If you find somewhere in your questions the content we are consuming, that means my job is done. Just change the level. Okay, so we did level soil texture. There was the first lecture I've told already. Start with the second lecture. It would be very interesting. I will also. So before when I start, we may give a bit of what was the last lecture we did study code. We said we did study about soil texture, soil segment, soil texture, soil segment, and different classification, different classification of size ranges of soil segment, soil segment. All right. So last we discuss about USDA classification of soil segments or segments. So there was the same types they were okay. There was 7 types: very coarse, medium coarse, fine coarse, and very fine. So there were this and the silt and clay. There were the 7 classification of USDA regarding the soil separate. So what was 7 soil separate? Soil separate were those particles their size was less than 2 mm. But what about those who have size more than 2 mm? More than 2 mm. More than 2 mm. What about those? Sorry for that. It was disturbance. I do live in a house. There is a lot of mess. So don't be more focused on that. So what about what about those particles? Those particles which have size more than 2 mm. What we call them? What is their classification? Let's go through with that. So classification of coarse fragment. The particles, their size is more than 2 mm. We call them coarse fragment. Okay. What are they? What are those particles? Those particles are coarse fragment. Sorry for the comment. I have not been doing too much practice of that. The English that I have speak that is only in the lectures. After that, I am a usual candidate from Rajasthan to speak only totally Hindi. So that formally just because of that, I'll try my best to be speaking English for the day and the lecture. Right. So what is the post fragment? Post fragment are their size is more than 2 mm. So there are the two types. There are the round particles, there are the flat particles. Okay, round or flat. So we'll go through with firstly with the spherical or cubic or round shape particles. So there are the five classification or five types of core phase with classified. What are the what are these five? First one is a gravel. Gravel is both. First is gravel, second is gravel, third is cobble, fourth is stone, and fifth is a boulder. And the most important is boulder one. It is big brother of clay in the importance. Big brother of clay in importance. Very important. Like we can after stars 2023, at the same time 2024 will come in the exam in when the world exists from the dinosaur era. All right. So we'll go through with the first gravel. What is the size? What is the size of gravel? Gravel size is just 2 to 4 mm. Again, the number that grade. Sorry for that. I speak every time when I get the number. I'll be the sorry for that. All right. This is the best way to learn. That is the best way to go up and on up these mistakes. All right. First in the gravel. First one is a gravel. So gravel is what it is the size of 2 to 4 mm. Then comes the paper. It is a classification for what? For the ground particles or spherical or cubic size. All right. Gravel. What is the size of gravel? 2 to 4 mm. Then comes the paper. The size of gravel is 4 to 75 mm. And what is the size of cobble? Cobble start will be 75 to 250 mm. Sorry, that name. Cobble have a size. Cobble have a size. Cobble have a size of 75 to 250 mm. That is amazing. All right. And we'll, uh, we'll, we'll go to the next one. Okay, we can write. The next one is a stone. What is a stone size? The stone size is start with the 250 to 600 mm. And last is the boulder one. We'll remember boulder. We wind up with the whole. First, then we write boulder. They is the important one. That's the size of that boulder is more than 600 mm. In the both the class period and one we'll go on in the next slide. We'll gonna study the next slide. If you guys, there are so many mistakes in my speaking, and so I do also observe. I forgot at the time of speaking. Sorry about the number, but for that, with the time I'll input to show it is not that I used to speak, but with the time I got lots of legs or lamb, you can say. I'll cover with the time these all the things. All right. Sorry for that. Again, start gravel. Size of gravel. Start with the 2 mm good. 4 mm. Then paper. 4 to 75. Then over 75 to 250. Then stone. Stone 250 to 600. And then boulder is model, simple model, and then all right. This is a for the round. This is the classification for the round shape. Then let's move to the next one. There is the flat one. Are you guys enjoying the lecture? If you guys find it bit of interesting, please hit the like button. That will help to get this video to reach one maximum population. So the student who come from the agriculture, they can get benefited with this content. All right. If you find any of slide sentence in your content that you are any bit of content that you are consuming from the slides, and if you are getting this content, this same content somewhere in your exam, that's mean my job is done. And it's a purpose of this course, like make you fall in love with the soul sense. That is the language itself exists for this course. So it's good to see you all, and it's the best part that in initial time I'm reporting these videos. Here audience of 30 to 45 people, there is good symbol, even though there are 82 subscribers. They make my confidence boost to go for the next one. So if you guys can share it to maximum, that it will be interesting. It is not for purchasing, it is not about making lots of subscriber again from all. So for that, it is not about to getting the maximum number of subscribers. It is just because I'm gonna be good in communication and gonna be good at my own content. I wanna divide the things. It do help in a two direction. It all like this is not for this is the disadvantage of the not having a student in the class. So they can help you to remember the thing that we are not here to study these kind of things. We are just here to learn the soil science. So that is our main agenda. So start for the next slide. So for that, so like classification of course segment. What is it? We learn the classification of cubic or ground particle. That next one is for that next exists for the straight particles. What is the classification? There are the four classification exist for straight particles. The first one is Jenner, then second is a Blackstone, then Stone, then Boulder. Boulder size is same in the both the classification. We'll go through these three. So let me get a bit of energetic, so it's a bit good in interesting manner, right? They are the classification for the plate particles. What is a plate particle? Plate particle, they are horizontally more developed and less developed in the vertical direction, correct? Okay, so in a classification of the cost segment for the plate ones, first we go with the channel. The channel hold the size of 2 to 150 mm. There was the sign. There was graver in a round one. There in flat one, the first start with the channel 2 to 150, 2 to 150 mm. Alright. There is another one is a flagstone. The flagstone hold the size of 150 mm to 380 mm. Simple as that. And the next one is a stone. The stone was in round one also. So what it hold? It hold the size of 380, 600 mm. And there is a, they end up with the boulder. Again, the size hold is more than 600 mm. So what did we study right now? So first one is a channel. It hold the particle size 2 mm to 150 mm. Then the next one is a flagstone. That hold the size of 150 to 380 mm. And there is a stone that hold the size of 380 to 600 mm. And there is the last one is a border that hold the size of more than 600 mm. All right. I think you will go it. Let's jump to the next slide. Specific surface area. Okay. So there is another new. Okay. There is a new topic table for the. Sorry for that. Okay. How many mistakes we doing everything. So quite all right. So we will end up we all right. So there is a new topic again. Is that specific surface area? What is that? Sorry for disturbance. For this class, how many times I mistake, I'll count with it. Mistake, too many mistake. So we'll go through with this again. Let's start from the specific surface area. Sorry for that, guys. I don't know. Evening randomly, so it's not my fault. So, all right, the specific surface area. What is the specific surface area? Specific surface area is a total surface area of the solid particles per unit mass, sorry, but usually based it is twice per gram. So, okay, interesting things here. Who is that guy? This is your host. Your host. Cheers, man. Cheers, man. I put this photo here just because there was that blank space. There was a blank space for photo, so why not? I should do the marketing of myself. All right, it's a joke. All right, what is a specific surface area? Specific surface area is a total surface area. It is the total surface area of solid particles per unit mass. Sorry, per unit mass. So let's we decide this is the diagram. There are the particles like that. They are closer in size, and there are the particles. So there are the particles. They are smaller in size. Why we need to fix the per unit mass? There is already mentioned. Usually expressed as the square per gram, like fixed area per unit. Six. Okay, so surface area is that in 5 gram soil there is a force particles. Okay, I'm explaining these things here. So in that 5 gram, there are the particles of sand that have surface area of like this, that cover that will be count like this, right? That is the surface area of this 5 gram soil. So maybe maybe I think I should keep the concept of size and surface area very simple. So we were here. Surface area is what? Surface area is the area of surface particles. Like there is a surface we hold in every particles. So, but what we talk about, it is an area of fixed per unit mass. So there is a fixed per unit mass. We took fixed 5 gram. So if there is 5 gram soil, so there is a surface area is different. Like in coarse soil, you have the bigger particle. In fine soil, the smaller particles. So area is fixed. So if that is the area, we can cover the 4 to 5 particles in that same area of silt or sand. There is those particles. There are the 5 particles in the same area, and there is a 1 particle in the same area. So how we can how we can understand this surface area? Like there can be these are the nutrients that these particles hold on their own surface, but there are lots of particles. It hold lots of these particles hold this nutrient. These particles hold this nutrient. This particle hold that plus nutrient. This particle hold that plus nutrient. So in that term, there is that much surface area, and in that case, there are the surface area is small particles. So the things I want to say, this surface area is not exist for one individual particle, for one individual soil particle. Soil particle. It exists for a group of particles. It exists for a group of particles. What we learn here? If the size is small, if the if the size if the size small, the surface area is small. Area is small. That's mean size is directly so directly in proportion of surface area. Like size will increase, then surface area will in proportion to surface area. So size will increase, then surface area will be decreased, right? They are opposite to each other. What is surface area? Surface area is this surface of that particle. That is surface area, but it is not talk about the one single particle. It talk about the group of particles at a time. So in this area, there is 3 particles. In this area, there are so many particles of smaller like silt and clay. So every particle holds some amount of nutrient, some amount of soil constituent, some amount. So in that case, the surface area is low. Like we can take these examples like this. I wanna make you understand very simple these things. I don't wanna exaggerate this thing too much because till now I when I was in the MSc classes, I don't even know that what is the meaning by that surface area that it is. I was thinking about only one particle. If there is a that much surface area, it is that much surface area, but there was no one there to explain me these things. So let us take again. Our agenda is not to cover it in a frequently manner, frequently this lecture. Our motto is to do this just to make you falling in love with it. So it's how much lecture it takes, we don't care about that, right? So surface area is what? It's a total surface area of particle. It's an area of surface particles, but it's area of surface particles. Are you getting to what is the soil particles we are talking about? Oh my God, I forgot to tell you. Sorry for that. What is the soil particles we are talking about? We are talking about sand, silt, and clay. we are talking about these particles, these three particles. So they say surface area we already studied before, who is bigger in size. So in that case, there are three particles in this area. There are many particles in this area of there is a sand, there is a clay, because sand is bigger in size and clay or silt is smaller in size compared to sand. So in that particular mass, there are three soil particles which hold that much nutrient only. So, but in clay case or in silt case, there are the many particles in that same area that hold the maximum amount of nutrient. There are the numbers of. So there are the two things we study: size of soil particle, and numbers of of soil particles. So what is this thing? If the size is bigger, when we take, when imagine that there is a hand of someone, or the more complicated, I don't wanna, or with the number of soil particles. So if one particle is bigger in size, that hold that much area only. But if the particle are small, they hold that much surface area. That much. Every particle hold their own surface area. So what we learn here, that simple concept, the size is surface area. It is because we can hold there is a limited amount of heat, but in that same area we can hold max amount of movement. So if size is small, then surface area is larger, which help us to hold the maximum movement, right? Let's provide the uh, larger surface area for the chemical reaction. It will carry what is the surface area? Surface area is the area of soil particles, area of surface of soil particles. But it's not about only for one particle. It's talk about the group of organic mass. That means in this area, only these particles, this area, there are the lots of particles. So it's talk about the group molecules. So there is only that much area. Yes, there is a lots of area in between them. The surface area is maximum in what? Clay or silt. Clay will more, then silt, then sand. This is the order of surface area. And all right, let's jump to the next one. Otherwise, it will be more complicated. I think. Okay. All right. So let's discuss why I put that surface area before we start. Just reason we'll get here. So we'll start with the sand. What is sand? Sand is a what is sand? We already study about the sand. So soil separate or it is a soil particles. So what does sand carry? Properties of sand. First we go with the size. We study about the size already. There was the two classification, USDA or ISS. In USDA, we will start with the two and we end up with 0.05 mm. And USDA, we started with 2, we end up with the 0.02 mm. All right. We already discussed this thing. Okay, let's get more energetic. It's damaging. It's getting important. So, talk about the basements, right? Sorry for getting just talking. Okay, so diameter, diameter or size we discuss larger than silt and clay. Yes, we already know this. Sand is the larger one. Sand is the bigger in size, then silt, then clay. Correct. Then silt, usually rounded. Usually rounded. Just when sand comes to mind, just remember the Goa beach. Goa, Rhode Island. You can remember the beach, there's a lots of sand. You have to see in so many pictures, so many videos. So there is the sand. Rounded in the shape or sub-rounded. What is sub-rounded or angular beach? It is like it is like a bit of that is the shaft. That is the shaft or that is the rounded. That is the rounded or sub-rounded. Uh, these are basic. I think you have an idea about it. So usually rounded in the shape and sub-rounded or angular, depending on the position. Position case required. How it's formed. It's the shape of particles depend on how so it form. So in reverse side, reverse side, particle are rounded, and the cross side the particles are angular, angular, angular or sub-rounded. Simple. All right. Surface the graph of it when we feel so in a hand, just you go on beach and pick up bit of sand in your hand. Just you will be just keep it on your palm and rub it between your thumb and your finger. You'll get the appearance or feel of sticky and rough. Sticky and rough. There is the when we hold the sand in your hand, when we hold the sand in our hands, so it feel like tricky or rough. His low surface area compared with sand, let's say we already learned that surface area, surface area is low. Like of sand, like it should be come in mind. Like sand particle is bigger inside, and clay particle is lesser than inside. So why sand is low and the clay has low surface area? The reason I already told you, we are not talking. It's true. Same one particle have larger area than the clay, but we are talking about fixed, fixed gram. Oh, sorry for that again. We are talking about fixed mass, like 1 gram soil, 5 gram soil, whatever it is that the amount of mass is fixed for that. So, like this is the only area. So there can be the certain particles in that same area for sand, silt and clay. So there is the one particle in that particular area. There is a several particles in that particular area. And what was the surface area? Surface area was this, but there are the particles, number of particles are very maximum in the number. So they create the maximum surface area ultimately. So that is the reason why the surface area is known for clay or silt and low for sand. Correct? Surface area is low for on sand. What is that? You can remember some. Okay. This is important to remember because it will see for examination, especially in GRL or SRL. Someone of these soldiers can just writing the exact things like with the time I learn all the things in a perfect manner, but it's not for me as well. I'm always not have been familiar with these things to writing and all, but in best of mind to write. What is the surface area of sand? The surface area of sand is 0.001 square per gram. All right. Let's move to the next one. Porosity and porosities. We did discuss bit of already about it. What was the pore space and pore size when the soil particles are arranged? Soil particles are arranged in a group, then their space is created between them, between it and there. There was two in previous lecture. I observe every mistake one time. It's all about the term formation. With the time, I'll be told it with this thing. So when the soil particles arrange in each other, there is a area is created in between the soil particles. That area is blank area is created that is known as the pore space. Let's go again on the same that we did discuss it, that we did discuss about the surface area sand. So there is a this pool like a fixed range of sand to 5 gram, 5 gram. There are the particle of sand. There are the particle of sand. There are things like that. What is this? What is the two things? Size of pore and number of pore. Number of pore. So you can see that there is a larger pore here. It is larger in size. Size is larger in sand case. That is sand. That is clay. So what is the scenario? In sand case, the size is larger. Let me here. Three particles. Sand. For the so this is the space. So in sand case, in case of sand, in case of sand, size of pore space is larger, but there is only one. It's 5 gram. But in another scenario, 5 gram is the mass, but they are the particles of volume is fixed. In same volume, we have number of pore space created state far more than compared to sand. There are the loads of pore spaces. we have. So number of pore space is high. Number of pore space is high, high, high in clay. So size of pore space is big in sand, but number of pore spaces makes maximum in clay. So that's a contradiction. If we calculate total pore space after this, who hold the maximum area of pore space? Total area of pore space. Which one? Just think about it. Take a pause and think about it. I think your answer, I think your answer would be sand, but it is not. When we go, when we go through with the calculate total pore space, there is only this space that sand hold, but there is a lots of space. Like when we calculate about the whole pore space, total pore space, that is maximum in clay because the because of the number of pore space is max clay, right? The size of pore space is maximum in this sand, but the number of pore space is maximum in clay soil. When we count every pore space into it become the more, it become the less. The soil particle size may be this, but there are the pore spaces created. One is macro and one is micro. We can see macro, which is bigger in size, that is in sand, but there is a micro that is in clay. The size, that should be the size. Yeah, there are the size. So macro pore space hold size of macro 0.08 m. Sometimes you find it more than 0.06. And in micro pore space, we hold just opposite, less than 0.088, or sometimes you find it less than 0.06 m. So simple as that. So what we done here, I am trying my best to go in deep dive these sponsor. Just we are taking more than 5 minutes. That only particular thing. That only particular things hold our 10 minutes, more than 10 minutes on that again and again. Why I'm repeating this thing again and again? Because I want to you guys to, you know, you should be like someone will ask you something regarding this, your mind blown in air. Like, all of this is not that complicated. These things I have been studying in my bachelor time. So I don't wanna, I don't wanna be big, like the same thing you will suffer from. So to make the better than this. Okay. So what we learn here, when the particle particle size is more than or space is less, right? We just go through with that, right? When the particle size is more, then or space is created in between them is less. All right. So it's a just Again, size and pore space relation for solid particles. So it's separate. Right. So what should be the order of pore space in the solid particles? Pore space should be should be maximum include pencil then set. Pores number of pores are maximum here, and we calculate the total surface area. What one surface area for photovoltaics. In that same volume, we calculate for the board, sand and clay, then clay is being hidden. Right. One thing I wanna say, porosity, it's uh, it's one lecture, one topic you can say. So we cover in very deep ahead these things. I think so. Don't be if you are not getting it, simply remember this. Take only one concept when size reduce the pore space increase. Simple as that. All right. We'll cover these things later on in very detail. Here, just I wanna give you an overview on that. Right? Sure. Again, porosity and pore size we study. Create larger pore, micropores. Imagine that. Imagine that, like there is a sand. So this is the pore space, and there is a plane. This is the pore space. It is like that. There is a pen. There is a pen cover, and there is a cable. There is a cable. There is a pen cover. So they are talking about in which we can hold our ink. Like it will fill direct. Okay, that's not. Okay. So imagine that if we fill the if we will fill the ink directly in the paint cover, will stay with it like the ink will be staying in this paint cover for a while. No, it will be goes up to from this side to the ground just because of the lead. But what in case in that when we remove our the needle or just give me a second, guys. Okay, sorry. Okay, we were here. If we direct fill the ink in the paint column, ink will not stay for a while, just it will be blown and will end up with the brown ink also just because of heavy. But in case of fill the ink in a refill, it will stay, will not suddenly come on the ground just falling, just start falling. Why it is happening? Because there is a force. There is a force of fall. We did a study about the two forces already in a previous lecture, adhesion and cohesion. So, what was the concept? Adhesion, therefore, H is for a similar particle is for different particle. And cohesion is exists for similar particle. So, there is attraction for what? There is attraction for what particle? We'll take it each year in case of Let's take it easier. There is a microphone. There is a microphone. There is a like this kind of things, but for to explain the easiest, we can go through it. Okay. Let's see what are these laws. So there is a force between wall of the force and water particles. That means a similar like the soil particles plus wall plus water. That is soil particles. Like this pore is created by like this. So there is a soil particle and there is water. So there is a force. Then the force is between a similar particle that is known as adhesion. So this force will be here because of the surface area, because of the size of pore is larger. I know guys, it's very time to explain this one side, but I'm gonna make it chop it up my mind this kind of thing. So we are here. So there is a force between pole and bottom. Like force is addition. Addition is weak just because of the size of pole is larger. There is a gravity will be more. Effect of gravity, effect of gravity will be more. The water flow to the water will flow very easily down lower. And there is another force between the what particle is there? There is a force between that is for the so that also will be feel just because of the gravity. Both the forces are the but in case of micropore, micro adhesion, and formation will storm. These wall of soil particles will hold water. They don't wanna make it go through with it. Just they hold it. So there is a quality of micropores and micropores. Micropores are not in the water, are not retaining in water or normal type. But in case of micropore, the scenario is different. Retain 10 4 don't polite in this thing is also clear to you guys. The larger pole, micropore allow rapid drainage. Rapid, what is meaning by drainage? The more of water from here is that way. Artificial or natural water drainage happens in the field. Okay, so drainage would be there, like in sand or in clay. How easily water can go through it in this fraction or in this fraction. Water can just simply move through with this sand very easily. You can see. So sand will not have the water retention capacity of clay particle here because there and one side is clay case that have maximum adhesion and cohesion. That's why they retain the maximum volume capacity. and the surface area also like particles. All right, let's go on to the weight intensity would be relatively there is some relatively heavy but size or nature 1.5 to 1.7%. What is the bulk density? We will not discuss it because these all are the separate topics we are going to study further. So I don't want to waste bit of time. Otherwise, this lecture will be for more long. So bulk density is high. They are talking about what it is that they would get, they carry the mass. What is density? Just to get any mass upon volume. The same mass, how much volume they can come, like there was the 5 gram. So there was the 3 particles of sand, but there was also particles of clay. So the pore space was maximum in clay, and there were less pore space in sand. So what's happening? So that's solid particles and the blank space is less here. The blank space and the pore space is more. So that's me. Where would be the weight maximum? Weight is some hold by solid or area that is covered by something. So in that case, we have the less pore space area, less pore space area. That's meaning we have something solid in this. So that means weight will be the maximum here. Let's say same volume, weight will be the base here, and then send I don't know because weight works according weight works just according to the velocity. Simple as that. Today, George will be at 30%. Otherwise, lecture will go all one. So, let's work to sorry for the license. Lecture boring. So, my point, okay, I do not have that much energy to speak. How I said, what is a nutrient retention? Water nutrient retention. We already told about that. There is a large surface area, there is a maximum surface area. So it's the water retention or nutrient retention depend on surface area. Surface area is maximum water. It is maximum clay. Is lesser in sand. So surface area is surface there can be every particle hold individual lots of nutrients. All right, and water particles the same goes to. But there is only this surface area can hold the nutrient and water. So we can understand the maximum surface area can retain the maximum number of nutrient and water. So this goes to simple as that. Sand can not hold nutrient maximum nutrient and water. It's over in that. Very low water holding capacity. We already know about the water holding capacity low just because of the size is maximum. The force addition correlation is very low. Yeah, so right. Low nutrient retention, low cation exchange capacity, low C. What is CC? Cation exchange capacity. It is a fluid formula. What is cation exchange capacity? Capacity of particles to participate in the exchange of cation. Like if they are the two things in the soil, they it's the whole space is carrying the soil solution. Solid solution. So there are the cations somewhere on the surface. If we come here, it goes there. This process is happening continuous on the soil. So they is cation. If they are doing simplified and simple as that. All right. So what is the next thing? That is color. Varies with the mineral composition. It changes with the what kind of mineral percent in the soil. So if quartz, sand, if sand is formed from the quartz, then that is have maximum quartz, that means white color. If sand is rich in feldspar, then color is yellows. So if the iron is on soil, it is color. All right, sand will change with the mineral composition. Simple as that. Other properties, low cohesiveness, low of them. Non-sticky, sticky is what? When water percent, uh, water will goes moves through the particles, when the more stay in the particles, then it will not sticky like that. It's talking about the presence of water we have when we have from the livings. So no plastic. Plastic is what? What is plastic? Is of soil. Capacity to mold. Capacity to mold. We cannot mold the cell in desirable shape. Like there is a no water retention, so we cannot make soil like we can make soil with clay, but we cannot make soil with the same. Just write it out. Let go. Can we make soil for a people who are studying with मिट्टी से खिलौने बनाते हैं ना that it thinks we are talking about. So there is a percentage like there should be more than 15%, I think 35 or 15. I'm confusing. There should be the percentage to make to hold the plastic in the soil. So sand is lower. Why I'm not going to know, too much problems, too much time there because these all are simple topics in soil science. We go through with them. And like just to remember here, can remember just honesty, not plastic. We cover these things later on in the training. Simple of the light soil. Okay, it's interesting concept. There are the heavy soil. There are the light soil. That which is color. There are the light soil. Heavy soil is what? It's soil required high energy to cultivate them. More power, more power to cultivate. It's just opposite of it, light soil. Then soil require less power to cultivate. If if soil require more power to cultivate, like in cultivation, yeah, if the soil is too hard, like the particles are the particles heavy, more photos, sun, correction force and pain. That there there will be the more force required to break that force to break down the aggregates. So there is a more cohesion force, more cohesion, more clear force. It is simple. It's more. It is simply so. There is a more particle-particle attraction between the three particles. So will require more energy, more power to break down this bond, this force between clay particles. So that means clay soil comes under heavy because it has high cohesion. Simple as that. But what about let's say same particle to the stage of micropores, no much infection, no much infection, no much attraction between them in the soil particles. That's when easily can cultivated like it not require to more energy, more energy to protect it. So less energy is required for cultivation of sand. So that's why the soil they have a maximum sand is for light soil. For us like what is light soil? Less power required for cultivation, simple as that. Correct? Sand can be seen in lakes like on beaches we can see sands by our tides like there's a microscope needed to see a cell. Sand can be seen by that simple as that. So, in how many people, right? So we should stop here, otherwise lecture will go too long. So I don't want to make more complicated for you. Like people don't want to sit for half an hour. They can sit for the half an hour, but they don't want to go for the 1.30 hours for. They want to sit for longer lecture. I'm going to that. I think this lecture itself a very number. It's my mistake. I'll keep in mind for like detail cover up these things. But there was a lots of concept. I think at the same time, it was important to cover at the same time. So not at all. That was not a mistake. But the important question was that to learn those questions was important. So sorry for that. Signing off. Cheers. Thank you.